This video is going to help kind of walk you through the process of stating the hypothesis for a hypothesis test. Stating the hypothesis is the first step in the hypothesis testing process, and quite honestly, it could be one of the most important because the hypothesis can affect the calculations that you do throughout the rest of the problem. So first of all, I've given you a chart of some common phrases that can be used to represent the various mathematical symbols such as greater than, less than, greater than or equal to, less than or equal to, and then not equal to. So you may want to make a screenshot of this particular screen so you'll have it as you work through the problems. So let's begin looking at some just kind of really straightforward examples, and then we'll move to some that are a little bit more involved. The first one reads, private universities' average tuition cost is more than $20,000 per year. One of your hypotheses has to be stated in the story. Now, this one again is very straightforward, and then you want to look for keywords and key phrases to kind of get a sense of what's going on. So you have, it says is more than, and I hope that phrase makes you think of the greater than mathematical symbol. So as we think about stating the null hypothesis and the alternative hypothesis, the null is labeled H sub 0 and the alternative is H sub A. This also has the phrase average in it, and that tells us which symbol to use or which population parameter to use, and that would be average, remember, is a synonym for the word mean, so we're going to use the Greek letter mu, the one that looks kind of like a funky looking U shape. And the fact that it's more than and it does not contain equal, it's going to go as the alternative. So the mean is more than $20,000 per year. What you have to remember in terms of which one you have is that the null hypothesis always and forever must contain equal in some format. The second thing to remember is that the null hypothesis and the alternative hypothesis are exact opposites of each other. So the one given to us is the alternative. The mean is greater than or more than 20,000. And the opposite of more than would be less than or equal to. Again, the null has to contain the equal. So there is your hypothesis based on the statement that was given. All right, look at the second one. The average age of community college students is 24.6. Okay, so the key word there is. Again, it talks about average, so that lets me know which symbol to use. Is, I hope, triggers in your mind that we need to use the math symbol equals. Okay, so we're going to state the null hypothesis and the alternative hypothesis. The one given in this problem, because it implies equal, would be the null. So we have the mean is 24.6 years. Again, knowing that the two hypotheses are opposites of each other, the alternative then would be the mean is not 24.6, because the opposite of is would be is not, or not equal. All right, the third one. The average score of 50 high school basketball games is less than 88. Again, you have the word average, which tells you the population parameter, and this one says is less than. And again, I hope that kind of triggers in your mind the symbol in mathematics, less than. So we want to state the null hypothesis and the alternative hypothesis. Since it's less than, which does not contain equal, this statement, the average score is less than 88, represents the alternative. So the mean is less than 88. Again, noting that the null and the alternative are opposites of each other. The opposite of less than would be greater than or equal to 88. Next, the average age of attorneys is greater than 25.4 years. Again, you've got the word average, which tells you which population parameter to use. And again, we use mu. So you're going to look for that phrase. And then you have the wording is greater than. And hopefully that signals in your mind the greater than symbol in mathematics. And so using that information, we can write the null hypothesis and the alternative hypothesis. You have to decide, however, whether it's the null or the alternative. Again, because it's greater than, which does not imply equal, it's going to be the alternative. So the mean is greater than 25.4. Noting that the null and the alternative are opposites, the opposite of greater than would be less than or equal to. So the null is the mean is less than or equal to 25.4. In the hypothesis testing problems, you're going to be given one of the hypotheses. You have to determine for yourself which one it is. And it all is based on the wording of the hypothesis statement. The next one says the mean life of an automobile battery is 36 months. In this case, they do actually use the word mean instead of average. So again, that tells us the population parameter to use. And you have the word is, which again, I hope triggers in your mind that you want to use the symbol equals. So to state the hypotheses, we typically write them with the null hypothesis on the top and the alternative on the bottom. We're using the mean, and this is equal is implied in the statement, so that would be the null. So the mean is 36. Since the alternative is the opposite of is or equal would be not equal. So the alternative is that the mean is not equal to 36. The next one, you are testing the mean speed. Okay, so you see the word mean of your cable internet connection is more than 3 megabytes per second. Okay, so more than, hopefully again in your mind, triggers the greater than symbol. So I'm going to write the hypotheses. Again, we typically write the null, which is denoted by h sub 0, and the alternative is h sub a. This one is the mean is more than, which does not in any way imply equal. So this is going to be the alternative. The mean is greater than 3 megabytes per second. Then the null is the opposite, so it's going to be the mean is less than or equal to 3. Hopefully you're getting a sense that you usually have the same pairing. Less than and equal to always pairs with greater than. Equal and not equal always pair together because they have to be exact opposites. Now let's take a look at one that's a little bit more involved. This is really more how a hypothesis testing question would be expressed because you have to have lots of information given to you. So it says, a manufacturer of chocolate chips would like to know if its bag filling machine works correctly at the 438 gram setting. It is believed, and that's one of the phrases you want to look for when you're thinking about hypothesis test. Okay. Usually your hypothesis, remember, think about science, is an educated guess. So it's what you believe, conclude, think, claim. So you want to look for those key phrases to find your hypothesis because it's kind of encapsulated in the paragraph. So it is believed that the machine is underfilling the bags and thus cheating customers. 37 bags were sampled and found to have a mean of 435 grams. Assume the population standard deviation of 14 using a 0.05 significance level. Determine if the bag filling machine is underfilling the bags. Okay, so here again, kind of at the end, it gives you the statement to determine if. So again, you kind of have that hypothesis restated. Now, you may have to think a little bit. What does it mean if it's underfilling the bag? Is it putting too much in the bag or too little? So you have to think about, is underfilling, does that mean greater than, less than, or equal to? I hope you make the connection. If you're underfilling the bags, you're not putting enough in there, so you're putting less in the bag than you're supposed to. So it's less than the required 438 grams, okay? Because it says the bag's supposed to work correctly at the 438 gram setting. So if I go to state my hypothesis, we have H, the null hypothesis, and the alternative hypothesis. Again, this statement implies less than, which does not include equal in any form. So the hypothesis stated in this paragraph would be my alternative. So the mean is less than 438 grams. The null would be the exact opposite. The opposite of less than is greater than or equal to 438 grams. Now that one's a little bit more involved because you got to kind of, in a sense, read between the lines. Let's see if we can do one more. A lumber company is making doors that are 2,058 millimeters tall. If the doors are too long, they must be trimmed, and if the doors are too short, they cannot be used. A sample of 24 doors is made, and it is found that the mean height of the doors is 2,045 millimeters with a sample standard deviation of 33. Using a 0.01 significance level, determine if the doors are either too long or too short, and we're told to assume the population is normally distributed. So here again, we're trying to decide, think about what our hypothesis is. And again, towards the end here, it kind of gives us the idea of what it is because it says determine, do we believe or can we claim the doors are too long or too short? Well, again, you have to think about what it means if the doors are going to be too long or too short. So we're basically trying to say that in a sense they are not equal to the required 2,058 millimeters. The doors are supposed to be 2,058 millimeters tall, but there's the option they could be too long or too short, so they're not equal to the requirement. So again, if we think about stating our null hypothesis and our alternative hypothesis, again, you have to interpret some of the words, but this one does imply not equal. So again, that means it goes in the alternative. So the mean does not equal 2,058 millimeters. If the alternative is not equal, then the null hypothesis is the mean equals 2,058 millimeters. I hope you find this video helpful.